Hello guys, and welcome back once again. In today's video, we are going to be conducting an exploratory data analysis. So basically our data set. So for our data set, it contains information related to positioning of product within a retail environment, focusing on the fast moving consumer goods. Uh, It aims to investigate the influence of various factors such as the product position, price, promotion, consumer demographics, and seasonality of the sales volume and consumer behavior. So data set is from Kaggle. So this is the data set and the information that I've been reading. So I've just lifted that information from here. So if you go through this information about this data set, you can be able to find out more information about the different columns and what they represent in this data. So I've just tried to lift some information from that. So generally, this is the data set and what it contains. And from this, we can deduce our objective. So for our objective, we will be exploring the impact of product positioning on sales and consumer behavior. So that's the objective. That is what we are going to be analyzing under this analysis. And for this analysis, we are going to be using exploratory data analysis to try to achieve this objective. So we're trying to achieve this through exploratory data analysis. So uh, basically, that's what we're going to be talking about today. As usual, before we get started, if you're new to this place, please consider subscribing. Hit that notification bell so that you never miss any of our video updates. Once again, thank you for your time, and let's get started. So as usual, we are going to start with the normal stuff that we all know. So one of those includes importing necessary libraries. So this is exploratory data analysis, and these are the common libraries that we usually use. So as we progress further forward, if there'll be some requirements for different type of analysis that we don't have those libraries or the modules installed, then at that moment in time, we will just install those modules and proceed. So after we have imported our library, we can we can print or display the first 5 rows of the data frame. So we first import our data, then we use the head method to just print the first 5 rows of our data frame. Then from this, we can do a data summary where you can obtain more information about your data. What is the data types, the null count, the number of columns, the number of entries, just to see what your data is all about. Then you can also check for duplicates as part of data cleaning exercise. So for the duplicates, I use the duplicated method, keep equals false. That means we're going to sum all columns, or all the rows, sorry, that are duplicated in our data frame, and give the total summation of those rows. If, as you can see, we are getting zeros, that means we don't have a duplicated rows. If we did have, then you can use the drop duplicates to do away with those duplicated rows. Okay. Another thing that we can do is about we can print the unique values for the categorical columns. Of course, our data frame, as you can see, it has both um, different various types of data types. We have the integer, we have the object, we have the float. But for this case, I'm just more concerned about the columns where the data frame is object. So we can call those categorical values, categorical columns, sorry. And then we can print the unique values under those columns, and then we can try to see their distribution. So for the first, we just do something like create a list for these columns. So we are selecting them using the select dtypes function, and we specify that we want the columns that have object as the data type. Then we create something like a list where we will do the frequency count. Then we use a for loop to be iterating over those columns, doing that count. Then we can just print the frequency count for each categorical column. So when we execute this, we can find that these are some of the columns, and we can see the different unique values under those columns, and the count or the count is just about the instances of that unique value under that respective column. So for example, we do have the column product position. Under product position, we do have different unique values. One of them includes the end cap, the ion, and the front of store. So these are the unique values under the column product position. And from the look of things, so when we product position describes the location within the store where the product is placed, such as the front store, end cap, and aisle. So that's all about that. And these values represent the count of the instances of these unique values under the column product position. The same applies to this column promotion. The same applies to the column foot traffic all the way until to the seasonal. So basically, that's how you can print, determine the unique values under the specific column. Then after that, we can move forward and maybe try to determine the distribution of these values under the column. Okay. So when it comes to distribution, there are two ways you can do. You can create a list for that, and this list basically can just come when you print this. So for example, when we print this column, we just add a new cell. So when we print this variable, you cut columns. I'm supposed to print this. So we can just do print brackets cut columns so that we only get the columns. So when you execute this, you can see we are getting a list of these columns under the cut columns. So with this, you can just repeat the same. So cut columns in cut columns, categorical columns in so we're just getting a variable for that. Remember that this is this, and this contains the list of the columns of the categorical columns in our data set. So after that, we can calculate the number of rows and columns based on the number of categorical columns and the subplots per row. So I've talked lengthy about this in my previous video. So if you get time, you can watch it and you can see how I did explain what steps you are taking from here. So basically, if you just go first on this, so this one gives the list of the columns. Then we are calculating the number of rows. So we want to have the number. We want to have 3 columns. Columns are the vertical distribution of those pie charts. Then we calculate the number of rows that we do want for this. Then length categorical cut columns. This just gives the total number of categorical columns that you do have in your data frame or a data set. Then we are adding the number of columns, this one. So for example, here we do have 1, 2, 3, 4, 5, 6. So 6 plus the number of columns, 6 plus 3, that is 9. 9 divided by the number of columns, I think we'll get 3. 6 plus 3, that is 9. 9 minus 1, 8. 8 divided by 3, you get around 2 pointer. 8 divided by that is 2 point, get a remainder of 2. Okay, but so remember, we only want the integer division, that integer. We don't want the decimal part of it. Then we create a figure and a set of subplots. We iterate through each categorical column and plot a pie chart. Then we hide any unused subplots from our chart. So we don't want to have plots where we don't have any chart. Then we can maybe adjust the spacing and possibly print. So when we execute this cell, so it's going to take some time because we are dealing with a lot of columns for this. So basically, this one is emptying into this, and then this process takes effect. Or what we can do, because sometimes this one takes a little bit of takes more time, we can just do this. Then we can do this. Then stop the previous iteration, then just execute this cell. So I think with this, it will work quite faster because we have directly providing this list. So as you can see, this is the outcome from that. So we have the different columns, and these columns do have different unique values. And from the pie charts, you can now see the distribution of these values under the specific columns. Okay, so that's about it. So for example, for the product position, you can see that 34% of the data points represent the IOL, 34.2% represent end cap, 31.8% represent the front store. In terms of promotion, we have where let's say, for example, a product for promotion. So for promotion indicates whether the product is part of a promotion campaign with values yes or no. So yes, 52.8 for 7 points. So basically that's all about the distribution of this. So earlier on we just printed out something like a list of those and the count, but here we visually represent this information using pie charts. You can also do the same for data distribution for the numeric columns. So this one we are just using a histogram, bin 75, figure size 13.7, and we just display. So when we do display this, you can see the different columns which are the numeric columns in our data, and you can see the distribution of data under these columns. For the distribution of data, we can in terms of distribution, we do have the normal distribution where we have that Bailey type of curve, but for this it's too rugged, so we can assume or say that for a conclusion from this is that for this case we don't have anomaly distribution of data in either in any of these numeric column in our data frame. Okay? So I think with that we have traversed a lot of things about the data that we are handling, and so we can then move to the elephant in the room. That's about the exploratory data analysis. So for this, I will be moving a little bit faster. So I've already written this code. So basically what we'll just be doing is I'll just be summarizing what we'll be doing. So under exploratory data analysis, I'll start comparing something like, so we start by comparing categorical columns with the sales volume. So basically I want to plot a box plot, and from the box plot we will be able to compare the categorical columns with the sales volume. Remember, in our analysis we are trying to the impact of product positioning on the sales. So we do have a sales column, the sales attribute, which I perceive that this is the target variable for this case. So we are going to see how these categorical columns are comparing that to the sales volume. So we will do this, we'll use the box plot for the categorical columns, and we will use correlation analysis for the numeric columns just to see that comparison. We are going to generate box plots, each comparing different categorical value with the sales volume. So we set our figure size, then select categorical columns representing excluding the product ID. So basically we are categorical columns. So for column in df.select data types, as we explained earlier. So we are selecting all those columns except the product ID. Then after this, we're just going to be looping through those categorical columns, and while we're doing that loop, we will be creating subplots and doing the plots. And when we are plotting, we will be comparing that categorical with the sales volume. And after we are done with that, we can maybe set title for the subplot. So when we execute this, you can add the plt.show here. Either way, we're still getting something. And when we, so this is the box plot. So the box plot, as you can see, I think we have the tail. This line represents the median. So I'll just explain this box plot with respect to this median. So as you can see, when we compare the sales volume and the product position, you can see that the median value is almost equal to for each IOL, NCAP, and front store. So generally, from the look of things, I don't think there is a significant difference for the sales for product position in terms of sales volume, because you can see that these box plots are almost the same height, their width are almost the same. Okay, the 25th percentile, you can see that region is almost the same. The same similar thing happens to the promotion. Similar things almost happen for the sales volume, though there is some this, but it's very small. Again, you can see the same thing happening here, the same thing happening. So when we compare the sales volume with these categorical values, you can see that there is no much significant difference. Maybe if we, from the look of things, when we conduct something like a t-test or an ANOVA, maybe we won't be getting a lot of a significant difference between, for example, the sales volume and the categorical attribute in this data set, based on the assumption we obtain from this box plot. We can also do the same for the numeric columns, but for the numeric columns, I'm not going to be using box plot, but for this we can just use categorical, not categorical. What is it? Correlation. We can just do a correlation analysis where we compare the numeric values and see the correlation existing between that. So for the numeric columns, when we execute this, again, we're just doing that something like a selection or sorting of our the columns that we generally need for this analysis. And by this, we are excluding the product ID column. Then we can create the correlation matrix. Then calculate the correlation matrix. Then from that, we can move on now, plot a heat map to represent this information. So this is the heat map. So we are comparing the sales volume. So I'm just generally going to explain what we are seeing on the sales volume. So when we compare sales volume and price, you can see we are getting this blue color. So when we look at this, I'm forgetting its name. So when you look at this, you can see that this in terms of correlation, this is a least correlation because 0.2. There's a small correlation between price and the sales volume. Generally, for example, if you increase the price, generally the sales decreases, and vice versa. So if you decrease the price, sales increase. If you increase the price, sales decrease. So we expect there should be a negative. Generally, there should be a negative correlation between price and the sales volume. When we look at the competitor price, this is just price. We're just comparing price and sales volume. So when you compare again sales volume and almost the same thing. So that's it. This diagonal is correlation between the same attributes. So when you compare competitor price and, for example, competitor price and and the price itself, again you see both competitor price and the price of the product itself. You can see that we are getting almost the prices are almost we are getting almost the same correlation value between the price and the competitor price. So it's a high correlation between that. So maybe the prices are not, they're almost the same prices, of course. So that's what we can obtain from that. So and after this, the one thing that we can do under this analysis is that we are going to do something about sales volume when the price is either higher or lower than the competitor. So let's determine what is the sales volume if the price is either higher or lower than the competitor. So generally, what we are trying to do is price. The price is the price of the commodity that we're trying to sell. Okay, but when you are walking into a store or a superstore, you'll find an item, but similar other items are arranged across to. So items that are of similar kind are usually arranged in the same shelf. Okay, so the price is the price of the items that you are selling, where the competitor price is the prices of the uh, competitor of the similar product. Okay, so we are going to see sales volume. We're trying to see if sales. We're trying to determine the sales volume if the price is higher, and also the sales volume if the price is lower. Then we do some correlation analysis to see if price has an effect in terms of the sales volume. Okay, so the first thing that we're going to do under this segment is that we are going to do a lot of filtering. So we are starting with when the total sales are of higher price. Okay, so we are going to say that for the price it should be greater than the competitor's price. Then for the sales volume, we're going to sum if we're going to do a collective summation if for those items where the price is greater than the competitor's price. So here we're just going to include those where the price is higher than the competitor price. So here, if I can just provide a comment here. So after this, then we can calculate the total sales when the price is lower. So similar to this, but now when the price is lower. So remember to the difference is just this. Forgetting their names, but I think you understand. So for this, then we can do some printing the results. So when you print the results, you can print this and this to see the sales volume. So when we print the results, you can see that the total sales so when you print, you can see that when the total sales volume, when the price is higher, you can see that when the price is higher than the competitor, you can see these are the total sales, and the total sales volume when the price is lower is 0. That means that we don't have a product which has a lower price than the competitor. So after doing this, let's see if there is a significant difference between these two means. Okay, so for the significant figures, then we can going to import the module for that. So SciPy from SciPy we're going to import that. Then we are going to filter the data in such a way that similar to what we did earlier. So there's no much difference. Filter the data for price higher and lower than the competitor. So just as what we did earlier, but we are not summing for this time. Then after this, we perform a t-test. So remember, we just have two means. So we perform a t-test, and for the t-test, we can use the t-test independent t-test. This one. And t-test statistics. Then from the t-test, we will be obtaining the t-statistic. We'll also be obtaining the p-value. So the p-value is it will be what will enable us to determine the significant level. So after we have determined that, then the next step will be about the testing for significance. So we are setting the significance level to be 0.05. Definitely this is at 95% confidence level. So we want to be sure at 95% confidence level. Then you can check if the p-value is either less than the alpha to determine the significance. So if the p-value is less than alpha, then we're going to print the statement saying that there is a significant difference in sales volume based on price compared to the competitor. Otherwise, if the alpha is greater, I think greater than 0.05, then we print the opposite statement. So from this, you can say that there is no significant difference in sales volume based on price compared to the competitor. So that means our T statistic. So let's try to print say T statistic. For the T statistics, just say T then we can print for the p-value. When you execute this, we are getting this statistic now. Let's see. I know why you're getting that, because this one is something like a 0. Okay, so the mean is 0. So when you do a comparison, maybe at this statistic, okay, but unfortunately for this, we are getting total sales value volume when the price is lower than this one to be 0. Fortunately, we are getting 0. But if you did have another mean value for when the total sales volume when the price is lower, then you can do a t-test to see if there is no significant difference. But for our case, since we are getting 0, then these results are going to be conclusive. Okay, or there is no significant difference. We are getting a 0, so we can't actually do a t-test for this case. But for a case where you do have a value greater than 0, for example, then you can do a t-test for that. Okay? And this is just for elaboration purposes. Okay? So we can also do another analysis. This one we are determining the product position and product category. So let's see, we are going to be grouping by product position and product category and calculate the sum of sales volume. So product position and the product itself. So what we're basically doing here is that we are looking at, for example, for the product position aisle, and we are looking at the different product category to determine, for example, which product has the highest or the highest sales in terms of volume when they are positioned at these locations. Okay, so that's actually what we are getting from this. And when we execute this cell in form of we are trying to plot a bar graph. So here we are using Plotly. You can see. So we are using Plotly to represent this information using a bar graph, bar chart. So for this, I will try to tweak a little bit this layout so that I can have a good look over these charts. So when we compare the sales volume of product position and product category, so basically we are looking at the different products placed at the different locations and see the product and see the sales volume for these products at this product location. So for the aisle, for example, if we compare clothing, we can see that we have the sales volume is higher when the clothing are placed at the end cap. When we look at electronics, so we can see that electronics again, when the electronics are placed along the aisle, that's where we get most of the sales. For food products, you can see that at the front store, that's where we get most of the sales volume. So by this, you can see how the different products are performing based on the location they are placed. We can perform an ANOVA test to see if there is a significant difference here that from the previous test. So from ANOVA, I'm going to first import the module for that. So I'm doing for the F1 way ANOVA. Then we are going to extract the sales volume for each product position. So that's this is what we're going to be using for that. So for the product position, then the sales volume for position in product position. So we look for the unique values under the product position. Then we determine the sales volume for that. Then we perform ANOVA test, where we'll get the F statistics and the p-value for that. Then by using this the results we are getting from there, we are passing in under this function. Then we print our results, then test for significance to see if there is a significant difference. So when we print our results, we are getting an F statistics of 0.12 and a p-value of 0.88. And since the p-value, this one is greater than the alpha at 95% confidence level, then this statement holds true, such that there is no significant difference between product position and sales volume. That means that it does not matter where the product is placed along the store, because the sales volume, due to that fact that due to those position is not quite significant. So there's no much impact if we, for example, if we place, there's no much impact in terms of sales volume if you're going to place, for example, clothing either at the aisle, the end cap, or the front store. So there's no much difference in terms of that. So placing our products at any of these positions might as well generate sales volume, might as well just generate sales volume for that specific product based on this ANOVA, test that we did. Okay, so that's about that. Then we can also determine or do another test where we compare sales volume and the foot traffic. Okay, so let's see sales volume and foot traffic. What can we get from here? So when we compare this, we can first group by foot traffic and the sales volume, where we calculate the sum of this. Then let's just plot a bar graph for this, so that we'll just do this. So in terms of traffic, we do have high, low, and medium type of traffic. So for the zones where we do have high traffic, I guess so. For example, the foot traffic represents the level of foot traffic in the vicinity of the product's location, categorized as either product location, so aisle. Okay, so this is the foot traffic at either the aisle. So for the positions where we did have high foot traffic, this is the sales volume, 598.166 hundred. This one is in hundreds of thousands. No, 599.166 thousand. For the low, it's 580, and for the medium, it's 590. So these bars are generally look almost similar. So even if we are going to do some ANOVA test for, if we are going to do ANOVA where we test for significance for this case, I bet we will just be getting that there's no significant difference. But let's see. So from the look of things, F statistics, p-value, there's no significant difference. Okay, for sales volume and the foot traffic. So we can also check the product position analysis, where we are going to check product position and product category. I think this one we have looked at this. Product position and product category. In terms of sales volume, if I'm not wrong. Let's see. But I bet this one we've already done. So product position, product category, and sales volume. This one, what we did, product position, product category, and sales volume. So this one we are kind of repeating the same thing. Clothing, electronics, you can see. This one, you don't need this one. We are repeating this. So product position, this one is sales volume and foot traffic. We can do product position. Earlier on, we did use ANOVA, but what we can do for this, although we did discover that there is no significant difference here, but what I do want is we can perform an F statistics, can perform an ANOVA test. So by this one, we want to go a little bit deeper, where we perform an ANOVA test to compare sales volume based on product position and product category. So for product position, aisles and sales volume, end cap and sales volume, front store and sales volume. So we're going a little bit deeper now to the values themselves, okay? To see if, for example, if we do an ANOVA test for the aisle and the sales volume, to see if there is a significant difference there. Okay, so that's the reason for this. So product position and the sales volume, and as well as the product category and the sales volume. Okay, for the individual product themselves, and for the product position and the individual product position. So we are comparing that to the sales volume. So we set the significance level at 0.05 and print the results and see what we are doing here. So again, when you print the results, I think what we're just getting is similar to what we got earlier. So here we got 0.88. Here we got F statistics of this and the p-value of this. And there's no significant difference between. So one of the tests you can use is the ANOVA. Also, another test that you can use is usually the Kruskal-Wallis test. It's a substitute. The Kruskal-Wallis test is a substitute of the ANOVA test. But for the Kruskal-Wallis, I think mostly it's usually used when you don't have data in a normal distribution. So if you have data that is not in a normal distribution, the best test for that is the Kruskal test. So basically, we're just repeating the same thing for this that we did in the ANOVA. But for this, we'll be getting the H statistic as well as the p-value for the Kruskal test. And everything just remains the same. So when we execute this, again, you can see that we're getting a H statistic of this and a p-value of 0.5. 0.5 is greater than our alpha. So there is no significant difference between the product position and product category in terms of the sales volume. So the individual, so we are looking deeper into the individual products or the specific position, and we are comparing that specific position, for example, aisle with the sales volume. Okay, but from the look of things, since the positions themselves, we didn't find a significant difference. So we highly anticipate that when we even look at the individual positions themselves, you can see that we didn't find any significant difference. So moving on to the next analysis that we can do for this case is about product position and foot traffic. I think this one, product position and foot traffic. Product position, product category. This one we did sales volume and foot traffic. So this is product position and the foot traffic. So product position and foot traffic. Product position, foot traffic, then we time the sales. Okay. So for the aisle, if for high traffic, this one is the sales volume. So for the aisle, if we have low traffic, this is the sales volume. For the aisle, if you have a medium traffic, this is the sales volume. The same as the other ones. So when we execute this again, what do we get? So this is the chart that we're getting from that. So basically, the blue represents the high traffic, low traffic is red, and green is the medium traffic. So you can compare if we did have higher traffic on the aisle, and for the this is the sales volume. For the end cap, when you do have higher traffic, this is the average sales volume, and the front store is this. In terms of low traffic, then you can see the sales volume for that. So this one we are sales volume comparison by product position and the foot traffic. You can also do another one where we compare product position and promotion. So we are going to analyze how different combination of product position and promotional strategies impact sales, so the sales volume. So let's copy this and we paste it here. Do this and this. So when we, for the aisle, when we did have no promotion, then we can see this is the sales volume. For the yes promotion, yes. For end cap, if we did have, we didn't have promotion, so this is the sales volume. If we did have some form of promotion, this is the volume as well as for the front store. And here again, just plot this. So for example, if we did have no, you can see despite us not having any promotion, you can see that the sales volume at the end cap was higher. So yes, you can see that despite us having a promotion, then most products in the aisle were sold for that, okay, than the end cap and the front store. So from this, we can shift our attention to customer demographics. So the customer demographics, by grouping data based on customer demographics and the sales, we are going to determine the most, for example, the most profitable demographic group. So let's see that. So basically, we are grouping according to consumer demographic and the sales volume. And the consumer demographic, we have the college students, we have families, we have let's say senior adults or individuals, and the young adults. So when we just do this and plot a bar graph to represent this, from the look of things again, we are almost at the same value, 450 for college students, around 443, 444, 431. So from the look of things, all these groups, there is no significant difference between the sales volume for these groups. So almost all groups are the same. So we can again shift. Let's do another one. So let's see. By grouping data based on customer demographic and product categories, you can examine how different demographic groups interact with the various product types. So basically here, we are dealing with customer demographic, customer demographic and product type. So that's what we are analyzing here. So we can just do the same grouping. So we just group. After we're done with grouping, you just plot because for this information, it's best analyzed using a chart. So from there, we're able to see the different, able to see how they're relating. So sales volume among different consumer demographic and the product category. So for example, if we look at clothing, you can see that college students are, in terms of clothing, they purchase most of their clothing, followed by families, young adults, then seniors. For electronics, you can see that seniors prefer shopping electronics. Okay, then you can see that they are followed closely by this one 139, this one 138. So by college students, seniors, college students, then young adults, then families, then young adults. For food, I would expect families. Let's see. For food, seniors, so they purchase a lot of electronics and food. Okay, then followed by college students, families, then young adults. So you can see how the different demographics of groups prefer different products. Okay, so even you can do another one where you compare customer demographic and the product position. So let's do this. Let's do that and see. So customer demographic and product position. Then we can move on to analyze customer demographic, product position, and the sales volume. Okay. So just do customer demographic. Customer demographic, and here we can just use product position. Then do sales volume. Then that will remain the same. When we execute this, this is the what we are getting from that. So customer demographic, product position. So let's see if we can represent this information in a bar graph. So customer demographics, then consumer demographic as our X. Y will be sales volume, product will be product position. Then sales volume among different consumer demo and the product position. So basically, we're trying to see where they like shopping, something like that. So when we look at the aisle, we can see seniors tour most of the aisle. Okay? And in the aisle, we found out that product position and promotion aisle, where was it? Product position and product category. So we did plot this one, I think it's the first one, product position and product category. So for the ion, we did see this, that most products of the ion are the electronics. So maybe you can just copy this and go do some comparison here. Okay. So we see that college seniors like touring the ion, and at the ion we can see that most product at the ion is the electronics. Okay? And earlier on we saw that in terms of electronics, we saw that who is the highest purchase of electronics? Seniors. So you can see that type of correlation. You can see that seniors prefer electronics, and these electronics are mostly placed at the ion. Okay. So at the ion, no, most of electronics are placed at the ion. Most of the product placed at the ion are electronics, and seniors like touring the ion. And so when they tour the ion, most of the product that they buy is the electronics. So something like that. Okay. So that's how you can do this. So when you compare again sales among product position, so at the end cap, you can see that at the end cap, college students like touring, visiting the end cap with respect to the sales, or they like purchasing products from the end cap. So at the end cap, we find out that what products are mostly at the end cap. Which products are largely at the end cap. The most product at the end cap are clothing. So clothing is the most product at the end cap. And you can see college students like touring the end cap. So let's see which is the most purchased product. Clothing. You can see that students like purchasing clothing. So they like touring the. So you can do some analysis where you target a specific demographic. So you are able to picture. You can basically track the movement of this individual, the customer demographics. So you are able to track their movements and see which products they are able to purchase at this location for most of the time. And based on that, you are able to position those products in such a way that they find them easy, based on their foot traffic, something like that. Then when you position those products appropriately, then you are guaranteed to get higher sales volume for that. Okay? So we have. Okay, so that was it. So let's, this one was, I'll do away with this. I just copied somewhere there. Then we are going to analyze based on what we were discussing earlier. We are able to then analyze customer demographic, product position, and the sales volume. So that one, let's combine those three things into one. So when we look at the ion, you can see that seniors like touring the ion. Senior students like touring the ion. Then at the end cap, you can see it was college students. College students like touring the end cap, and the front store. I'm giving my money to families. Oops, college students. Yeah, college students again like visiting the front store. And at the front store, that's where what products are mostly found at the front store. Front store, you can see that most of the products are clothing, but you can see that at the front store, clothing, most of these types, this clothing will be again for the college students. Okay, so that's it. So that's from that. You can also do another analysis, where we are going to determine consumer demographic responsiveness to product price. Okay? So responsiveness to product price. Though we did found that if the price is higher, if the price was lower, we didn't find anything. So basically, here we are going to filter data on the for price higher and lower than the competitor's price. So we did that. Then calculate sales volume for each case. So we calculate the sum of that. Then print the results. So generally, as we saw earlier, we did find out that the price for the different commodities or for the different products was not even was higher in all instances. So consumer demographic response. So we can see that even if we do statistical significant difference, we can see that we are not getting, there is no significant difference. That means price of the competitor and the price of our product does not affect the sales volume, something like that. But since we got a zero here, we're going to do, you can just repeat what we did earlier, then determine if the price is lower or the price is higher. If there's a significant difference, that means that price do have an effect in terms of the sales volume. But since you're getting zero, I'm not going to do details for that. Okay? But we can do something related to this, where we do a consumer demographic responsiveness to promotion. So let's see if there is a promotion, there is it will affect the sales volume. So we are going to group our data based on consumer demographic, promotion, and calculate the sum of the sales of the volumes. So when we execute this, you can see how the different consumer demographic respond to promotion. So I'm just going to plot Nini for this grouped bar graph so that we can be able to visualize this information. So let's look at yes. So when there's a promotion, you can see generally 211, 196, 219. You can see again this. I don't think there's a significant difference in terms of sales volume when there's a promotion and if there's no promotion. So you can see that for no promotion, you can see for the seniors, if there is a promotion or no promotion. For the no promotion, we can see that the sales volume is quite a little bit higher than the other consumer demographics. Okay, so let's see of another analysis. So here we are going to consumer demographic, product category, product position, and the sales volume. So let's see. So we can group our data based on these metrics. So consumer demographic, product category, product position, and the sales volume. Then from this, we can move a step further. So for example, let's sort information about seniors. Let's see. So let's go a step deeper and see, for example, for the seniors. So we started by grouping our data based on consumer demographic, product category, product position, and the sales volume. Since these are 4 columns, plotting this will be somehow challenging. So we're just going to sort out for the seniors and to see how the seniors are performing based on product category and the product position. So we can do that and move forward and load. So in terms of seniors, so earlier on we saw that seniors liked visiting the electronics. I think it was electronics. So for electronics, most of the electronics that seniors purchase are in the aisle. So if you're going to stock something to do with the electronics, you can do that at the aisle, where earlier on we saw that seniors were likely to, they were, this is a product position, seniors, product category. Yeah. So for electronics, we did see that seniors like purchasing the electronics. And here we can see that the same seniors, they like purchasing these at the aisle. So when you are going to stocks electronic products, so we look for spaces at the aisle where most of your buyers like buying those electronics from. So for food, for example, seniors like purchasing their food in the front store. So if you're going to purchase to stock uh, food specific for seniors, then try to stock that at the front store. So we can move to another demographic. Uh, this one is for the young adults. So this one will be for families. Seniors, you can just change these two. Just to young adults, not seniors. It's just the same. Young adults, group young adults, young adults. So for young adults, so if your niche is for the young adults, then product position says volume, product category. Okay. So for the young adults, we can see that when it comes to clothing, so young adults purchase their clothing mostly at the end cap. Okay. Clothing, yeah, the end cap. Electronics again at the end cap. Uh, Food at the front store again at the end cap. So you can see that young adults like touring the end cap. That's where most of their products are located. For families, we can also do the same. So for families, uh, for families, clothing they prefer that at the end cap, electronics at the aisle, and food at the front store. So when for families, then you can see that they really like walking around. So for clothing, you can see most of the clothing are from the end cap. When it comes to electronics, at the aisle. When it comes to food, the front store. For college students, so this one for this analysis, as you can see, we are trying to narrow down the different consumer demographics to kind of able to map uh, their their positions or how they do their shopping under the store. So this one will be for college students. And this one will be for families. college students. So college students, that's it. Then plot. For college students, you can see that most of their clothing is from the front store. Uh, for electronics, most of that is from the front store again. Food, most of that is from the aisle. Okay, so basically that's it. So with this impact, with this analysis, from the look of things, you can now see the impact of positioning product at different locations and how they affect. So from this, we are able to deduce and find out that uh, uh, able when you are able to map the locations where the different consumers like purchasing their products, then it will be quite easier to make life simple for them so that they can able to find these products at the exact location. Then it increases the likelihood of them purchasing. So this was just like a first overview of how we can do such an analysis. As we saw, this was about the impact of product positioning in terms of sales volume. So I was a little bit fast on this, but from the look of things, you can do an exploratory data analysis where you do some comparison of product position at a different location to see if there is some impact in terms of sales volume. Even though in terms of when we do a significant test, we didn't find most of these to be having, for example, a significant difference. But when we look at basically now we'll be just be forced to look at the sum total of the sales volume. But we saw uh, that different consumers do visit. There was a variation. There was no common theme in terms of where these different consumers uh, visit to buy these products. We saw some variation in that. So basically, if you are going to stock your products into these shelves, then you need to understand uh, uh, your customers, where they do like visiting and what products they do like purchasing at those respective places. Once you have understood that, then it will be quite easier for you to do those product, positioning in the sense that you can maximize your sales volume. So again, this is another way that we can use or we can apply uh, exploratory data analysis to any particular data in such a way that we need to understand the intricacies of the data. Then from there, if I'm going to build a model from this, then having this type of understanding, then it will be quite easier for me to build such a model. But that can be applied when you are now building a machine learning model to be able to any enable any company or anyone trying to best place their position to their products to try to increase the number of sales. Okay, so basically that's it for today. That's all from my side. Today, and I'm going to stop here. So once again, before we end this session, I would like to thank you for your support. I want to thank you for all those everyone viewing for your support. I'm very grateful for that. Um, I will wish you to please share with your friends and anyone interested in data analysis, data science. So before we end, please consider subscribing. Hit that notification bell so that you never miss any of our video updates. You can also like this video on your way out. Even if you have something to tell us, any comment, review, you can just reach at the comment section. We'll try as much to get back to you. Once again, thank you for your time. I'm very grateful. See you in the next one.